Hello there everyone, you've tuned in uxwbill, and today I present for your hopeful viewing pleasure a follow-up to the Comfortmaker air conditioner repair and maintenance video that I made, what was it, about 2 weeks ago maybe just a week ago. It's hard to tell. Time flies when you're having fun, and I'm not really in the frame of mind right now to make a video, plus I've got a lot to do today, but I did kind of insinuate that there would be a follow-up to that video where I showed you what repairs I was going to make and actually went ahead and implemented them. So let's go ahead and take a look and see how things stand right now. Looks like the trees have wasted no time at all messing this thing up again. You've even got one that's growing up here. Probably poison ivy or something. That's what I'll probably get for trying to smash it and get rid of it. Should come back here with some kind of loppers and cut it off. But what we're going to go ahead and do today is install a replacement contactor. This is the brand new shiny one that's going to go in there. Replace the old one that's a little bit worn after many reliable and faithful years of service. I decided to leave the capacitor alone. I know it's a little bit out of tolerance on the compressor side, but the truth of the matter is this thing has never exhibited any difficulty whatsoever in starting up. It's never failed to do that other than as a result of the blown fuse that we had from the first video. And if I did put a new capacitor in there, it wouldn't be nearly the level of quality that the original was. So it wouldn't last anything like as long, and it might fail in a very dramatic manner. So even though the capacitor that's in there is, about 8% off value, give or take a little bit, it's still working just fine. And since it will be much more reliable than any replacement you can buy today, I'm going to go ahead and leave it. Although Aerovox, the company who made the original capacitor, is most definitely still in business, and they claim they still make products for the HVAC market. I just don't know how you actually go about getting your hands on one, unless of course they're only available to the major manufacturers. So let's go ahead and pop the covers off of this thing and just see what's going on and get things underway here. And here we are back again in the good old electrical compartment of the Comfort Shaker. I am somewhat surprised and pleased to report that the spiders have not been nearly so diligent as the trees have. It looks like maybe they might have started work in here again at rebuilding their home, but they certainly haven't made a whole lot of progress. So now what we're going to do is actually go through the motions of replacing the old contactor with the new one. And because I'm only one person with one pair of hands, and realistically no HVAC technician is going to bring a camera tripod on the job site with him, that means that the recording is going to stop right there. But before I ever put my hands in this unit, I want to go ahead and make sure that everything is in order. And one way to do that is to make sure that the power is disconnected, which it obviously isn't right now, but there is actually a reason for that. I've got my good old Harbor Freight multimeter right here. This is the one I usually use for almost every task I have around the house. And as with any multimeter from any brand, no matter who makes it, because they can fail at any time and might do so without warning, you always want to go ahead and make sure it works. And that's why I left the disconnect in, so I could just stick the leads right across the contactor's input here and just verify that I do in fact have the correct voltage, which right now is a little bit high, but that's just the way things are around here. And when I've complained to the electrical utility about it, they always get smart with me and say it's intolerance. But that really doesn't matter. All I wanted to know was that the meter did in fact work properly. So with that done, we'll take the disconnect out and we'll put it all the way over here. So I'd have to make a very concerted effort to go and get it. There's very little chance of my doing something accidentally. And now that the disconnect is out, we'll check again, if I can do so. I did it so easily the first time around. Still got about 1 volt on there, but that's nothing of any consequence. That's just an induced voltage that's coming from somewhere. And there we go, folks. The new contactor is in place. I did have to make a small adjustment to the wiring. The original factory wiring in this air conditioner had these lug-style terminals on it, and they simply went around the screw in the contactor assembly that held them into place. The new contactor, being a little bit different, is really only intended to accept push-on style connectors, which I simply reused. But for the wires that had lugs on them, I simply stripped off some fresh wire and then tightened down the bare wire underneath the screws. The power coming into the unit was already done that way, so I simply cleaned those up a little bit, made sure they were in good condition, and then I put them right back into place again. I don't know if you can hear it in the background, but every now and again I hear someone playing some sort of a woodwind instrument or another. I guess it's band practice. Of course, school starting up around here happens in, what, another 2 weeks or so? It's hard to believe. Where'd the summer go? Not that the summer's over. Oh no, we'll still have plenty of hot weather left after this. So now, with everything in place, the question is, have I fixed it? Have I done enough fixing of it yet? If it still works, we'll have to try and fix it some more. But if not, we'll... Never mind. That really didn't quite turn out the way that I intended. So what we're going to do here in just a moment is put the fuse disconnect back in place. I'll go into the house, I'll turn the thermostat on, and request a call for air conditioning, and we'll just make sure that this thing goes ahead and starts up as it should. Alright folks, here comes the real test, the smoke test, such as it may be. The idea being that if it smokes, we obviously have fixed it enough, and I know I will not give up with the painful puns. I'm going to go inside right now in real time, no video editing or other trickery, so you'll know exactly how long it takes me to get there. And I'm going to tell the thermostat that I want to call for cooling. I've gone ahead and plugged the disconnect back in, so we'll just see what happens. Hopefully I've made sure that none of my tools are going to shake off and fall into the unit. I think I'll go ahead and move these. As for the others, we'll just let them fall behind it because that would be really convenient. Here I go. I don't know why someone left the exhaust fan on. Probably know the guy that did it though. Smoke coming out of it, so it must have worked at least to an extent. I guess the next thing to do is go ahead and slap the amp clamp on it just to see what's going on with that. Of course, it wants to face a way that I can't actually readily see it. Here's the amp clamp all hooked up. There's the reading on one leg of power, and there's the reading on the other leg of power. You can definitely tell it's a hotter day today than it was when I made the first section of this video. And there we go. For years down the road, when I've forgotten about doing this, I left a note to remind myself. So everything that you just watched was recorded in August of 2018 or thereabouts. And it's only here in April of 2019 that I'm getting around to actually finishing this video. Boy, there's nothing like that getting things done spirit, isn't there? Anyway, this is the factory original contactor that was supplied with the Comfortmaker air conditioner that was attached to this house. It was manufactured in the United States, which gives its age away right away, and I believe the company that made it no longer exists. It was manufactured, same as the control transformer on the furnace in the house, by a company known as Products Unlimited. And I believe that although these are considered to be a throwaway part in this day and age, that the nice people at Products Unlimited actually intended for this thing to be renewable in the field. I also thought it would be interesting to show you what happens to these things. One of the most common modes of failure that these things will experience. So let's go ahead and get started. Now I'm actually working from memory here. I had intended to finish this video a whole lot sooner than obviously I'm getting it done. And so I took it apart way back then just to make sure that I knew how to do it so I didn't look like a major doofus on camera. But now of course I've slept several times since then, and naturally I've forgotten, so I'll probably end up making myself look like a doofus in short order. But let's go ahead and start at the very beginning here. We'll just go ahead and undo this one screw that holds the pressure plate for the electrical contact in place. And then we'll remove this smaller screw in here. And when I do that, if memory serves, I believe that with some finesse, and finesse of course is not my strong suit, that this contact will be free to come out, and indeed it is. And then of course you can get at this other contact in here, and this would really be a lot easier with the needle nose pliers. But if you know anything about me, you know I'm never interested in doing anything the easy way. So we'll go ahead and see if I can coax that out of there without actually having to go and get more tools than I have. It may be that I have to get the other terminal out of there first. See, I told you I was going to make myself look like a doofus on camera while I was trying to take this all apart for you. Alright, and of course I don't have a bladed screwdriver with me to do the other side in case that screw needs to come out. I can just imagine the caning in the comments that I'm going to get over this. Alright, I'm conceding defeat. I'm going to go get a needle nose pliers. Well, unfortunately, as life would have it, neither Bizarre Furhead nor the Keykeeper left out a pair of needle nose pliers suitable for me to come along and steal. So, with a little bit of finesse involving one of my bladed screwdrivers, I did in fact manage to get the whole contactor apart. And what you're looking at right here on your screen are the working surfaces inside this contactor that actually serve to energize the load whenever the coil pulls in after the thermostat completes the circuit that allows it to become energized. Any electrical switching contact undergoes a lot of abuse whenever it opens or closes, especially if it's powering any sort of heavy load, especially a highly inductive load like a motor, as would be found in the compressor and the condenser fan on the typical air conditioning unit. And the result is an electrical arc every time the contacts make or break. Now, without wanting to go into an absolutely terrifying amount of detail here, I believe that I would be correct in saying that as you approach the zero crossing point and ultimately arrive at it, that would be the best time for the switch contacts to close, because the voltage and the current alike on an alternating current line are going to be, you guessed it, at zero potential. But there's no guarantee that's going to happen when these contacts close, so if you're particularly high at either point in the cycle, there's going to be a considerable amount of current and voltage there to flow, and the result is going to be a contact arc. Now, switch designers, of course, do consider this sort of thing, and if you look at these, you'll notice that they have a sort of silvery-looking metal, and that metal is, in fact, actually a light coating of silver, because silver is a good conductor of electricity, and it's also fairly resistant to the arcing damage, much more so than, say, a copper or a steel terminal would be. Gold would be even better in this regard, as far as resisting the damage caused by an electrical arc. But gold, of course, is quite expensive, even in the minute quantities that would be required in every one of these switches that's manufactured. So silver is what they use, but eventually the silver gives in, and when it does, the damage starts to get worse and worse and worse until eventually you have this burning effect that you see here in the contacts. You can also see that the switch never closes in exactly the same way twice, based on how the damage is distributed across these. Now, if you ever came across a contactor or another electrical switch that was damaged in this fashion, you could restore operation by simply burnishing the contacts with something like emery cloth or a fine sandpaper, but that fix will be temporary at best because the silver coating has been damaged and the underlying less noble metal is not going to be as resistant to the damage caused by the electrical arc that's formed whenever the switch contacts make or break. Alright, there we are back together again. As always, I'd like to thank you for watching this video. And I certainly look forward to hearing your constructive commentary and questions down in the comments area.